Hello, PreCalc. You'll be viewing this lesson on 9/15 Thursday after class at some point. And we're going to call this lesson Special Triangles and title that area in your comp book Special Triangles. And here are the definitions that will help us. Have you found a little way to memorize that? It's got to be in your memory very soon, if not already. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember, this only deals with right triangles. And this is adjacent, this is opposite, and here's our theta, and this is hypotenuse. Alright. Yesterday, or the video you saw, would give you a triangle which had a missing side. And you could calculate that missing side because it was a right triangle with the Pythagorean theorem, and then complete the sine, cosine, or tangent requirement of u. So today, we're going to get more powerful than that. I'm just going to give you an angle, and you're going to give me the sine, the cosine, and the tangent. So to do that, you have to know about two very special triangles, and we'll develop them. So say you have a triangle. Because I'm going to split, I want to try to think of the simplest triangle that I can. So all three sides are equal, and you think maybe the simplest one would have a 1 on each of the sides, but since I'm going to drop a line and cut one of the sides in half, I'd rather have whole numbers to work with. So I'm going to call this side 2, this 2, and this 2. So now I'm going to drop a line. Well, before I do that, if you have three sides that are equal, and all three are across from equal angles, and they all have to add 180, of course. So what is the value in degrees, speaking Babylonian for a little bit? I noticed Pastor Andrew mentioned Babylon. Did you hear him in his talk today? Well, anyway, all right, it's not today now. Back on chapel yesterday. So this has to be 60 degrees, 60 degrees, and 60 degrees. So they're all going to add up to 180. They're all the same, so it must be 60. So now I'm going to drop a straight line down from this vertex to the opposite side. And it's supposed to cut it in half. Mine looks a little lopsided, but make yours visually pleasing. So it's going to cut the two into 1 and 1. So remember, since I've dropped a perpendicular, this is a right angle, and I've cut this degree from 60 in one side here is now 30. That is my special triangle. I'm going to cut it out of the board and remove it to a place where I can work with it better. So I'm not sure if colors show up on this video very well, but I'm going to remove it down here. And here's the special triangle. And this side is 2, this side is 1, and this side I'm not sure of. So this is my angle theta. This is 90, never mind, it's not theta. We know what it is, it's 60. Theta is for unknown angles, not known ones. This one is 30. So all I need for this special triangle is this value. So would you Pythag it for me? See what you get. Pause the video and see if you can use the Pythagorean theorem and find the value of this side. I'll work it out. So pause and then put us back on and see if you got this. I'm looking for this side. I'll call it side x. Pythagorean notice, the Pythagoras notice 1 squared plus x squared, that's the sides of the triangle, a squared plus b squared, equals the hypotenuse squared, in this case, 2 squared. So when you set it up that way, make sure that the hypotenuse is on the side of the equal side by itself. Equal side. The side of the equal sign by itself. Get it? Eraser. So solving that for x, subtract 1 from both sides, so we get x by itself. So this is 4, bring the 1 over by subtraction, and we get x squared equals 3. Take the square root of each side, and we get x equals the square root of 3. So the square root of 3 is the third side of this special triangle. This special triangle is called the 30, 60, 90 triangle. It has several secrets in it that will impress you and you can use it to impress others. From it, without any calculator or anything, say the electronic cloud has been released on us from some enemy of ours, and it turns out that people need to know the sine, cosine, and tangent of angles without a calculator. So they come to you, pay you big bucks to tell them what is the sine of 30, the cosine of 30, and the tangent of 30. What are those values? Well, it turns out you remember your special triangle because of the 30, 60, 90 always is proportional to these numbers. So we'll take the smallest set of numbers and this side across from the 30, since 30 is the smallest angle, it's across from the 30 is the smallest number, 1. And 2 is the hypotenuse. So hypotenuse is 2. And then it looks like easy 1, 2, 3. And you have to recall that the 3 is under the square root. So 1, 2, square root of 3. 1 always across from the 30. 60 always across from the square root of 3. 2 always across from the right angle. Alright, so now we can fill these in. The sine of 30, here's the angle 30. We want opposite of 30 divided by the hypotenuse. What side is opposite 30? 1 divided by the hypotenuse of 2. What's the cosine of 30? We want the side adjacent, not the hypotenuse, but the other side. Cosine is square root of 3 over hypotenuse 2. And tangent from 30 is opposite over opposite over adjacent. 1 is across from 30, side opposite, and adjacent is square root of 3. This, however, has to be rationalized. We never leave square roots in the denominator. So we have learned in math past how to rationalize, which means to get the square root out of the bottom. So we have square root of 3 on the top. Square root of 3 times square root of 3 is 3. And